Hello, this video is to cover evaluating algebraic expressions, and this part is really with the Coreq part of our course. This is going to help you with some of the things that we do in the future. So I'm going to start out with the value of an algebraic expression depends on the values of the variables within the expression, and we will evaluate the expressions for the given values of the variables. And so essentially we're just taking values and we're plugging them in. So for x plus 4y minus 2z, where x is equal to negative 2, y is equal to negative 7, and z is equal to negative 12, I'll just be plugging those values into their respective variables here. All right, and I'm going to use parentheses when I do this to show you. So I have x plus 4 times y minus 2 times z, but I'm writing it with parentheses because I'm about to plug things in. Since x is equal to negative 2, I'm going to place negative 2 in where x would go. And y is equal to negative 7, so that will go in place for y. And z is equal to negative 12, so I'll put a negative 12 in place for z. And then from here, I'm just going to evaluate what that numeric result will be. And you can do this by hand or by calculator at this point. I would probably do it by hand, but I would definitely check it with a calculator because it's really easy to make a mistake. You should end up with negative 6. And if you want me to work it out by hand, it would be negative 2, and then plus 4 times negative 7, which is negative 28. And then this negative 2 and negative 12 does become a positive 24. And so I have negative 2 plus negative 28, and that would be negative 30 plus 24, which does indeed give me negative 6. All right, number 2. Negative a minus 2b plus 5c, where a is equal to 31, b equals 22, and c is equal to negative 4. So I'm going to do a similar thing. I'm going to be plugging these different values in, and I'm going to use different colors to help you. And, I believe c here, c should equal negative 4. Sorry about that. It looks like the negative is in the wrong spot there. All right, so I'm going to have negative a minus 2 times b plus 5 times c. And then I'm going to plug in all of these different values. So for a, I get 31. I'm going to plug 31 in. For b is 22. And then c is negative 4. And so it's going to look like this. And then I'm going to work this all out. And I end up with negative 95. All right, and then like I said, you can definitely go back through and work that out by hand if you would like, or you can practice with your calculator because there's going to be some problems in this class that are really advanced and you're going to actually have to use a calculator to solve it anyways. So I like my students to get used to that calculator pretty quickly. All right, so let's move on to what we call function notation. So it says determine the function values. We're going to let g of x equal 9x minus 8. And what we're going to do is we're going to find these different values at their respective values for x. So g at 0 basically means we're going to be plugging 0 in for x. So it's going to be 9 times 0 minus 8. And I'm going to work that out in just a second, but I want to show you what that function notation looks like for the rest. So for g at 2, I do a similar thing, but I'm going to replace the x with 2 instead. And then for negative 1, for g at negative 1, I'll be replacing x with negative 1. And then I'm ready to go ahead and work all that out. So this becomes 9 times 0, which is 0, minus 8 is negative 8. 9 times 2 is 18, minus 8 is 10. And then 9 times negative 1 is negative 9, minus 8 is negative 17. All right, let's keep going to number 4. So on number 4, we have one of our most popular functions you'll see a lot, which is a quadratic, this 4x squared minus 2. So h of x is equal to 4x squared minus 2. We're going to find h at 0. So remember, that means we're just going to replace the x with 0. And then for the next one, we're going to find h at 4. So same thing. I would have 4 times 4 squared minus 2. And then last, we have negative 5. And this one is kind of special because a lot of students get this wrong on the first try. And so you want to make sure to wrap it in a parentheses hug. That does matter, especially if you're going to use your calculator to evaluate the expression. All right? Okay, so when I do letter A, h at 0, I end up with negative 2. And then when I do h at 4, I end up with 62. For h at negative 5, I end up with 98. And like I said, be careful on this problem because this negative 5 squared, if you don't use parentheses and you type it in your calculator, you will get it wrong because it does order of operations. And so it will, it'll square the 5 and then multiply by negative 1 if you don't use parentheses. But we know that negative 5 squared would be negative 5 times negative 5, which is positive 25. And then 4 times 25 is 100, minus 2 is 98. It's just really easy to make a mistake on that last one. All right, let's try a few more together. So for number 5, we now have a rational function, which you will also see sometimes in this class, and we're still doing the function notation. So h at 6 simply means I'm going to replace the x with a 6. So I'll have 1 over 6 minus 4. And even though I put parentheses there, because that's a positive 1, it doesn't really need to have parentheses, but it is a good habit when you're plugging numbers in to use parentheses, just to get used to that, because in the more advanced problems it would matter. But since this is a positive 1x, it really wouldn't change anything if I didn't put a parentheses there. Okay, so now I have 1 over 6 minus 4. 6 minus 4 is just 2. So I end up with 1/2. 1 over negative 3 minus 4 would become negative 7. And I just want to point out that 1 over negative 7 can also be written as negative 1 over 7 or negative 1 over 7. All right, so you can write that 3 different ways. And then for letter C, I have 1 over 5 minus 4. 5 minus 4 is 1. And then 1 over 1 reduces to 1. But feel free to use the calculator to check these as well. All right, last but not least is number 6. So we are evaluating the square root of x minus 2. And we're going to find n at 2. And so I'm going to have the square root of 2 minus 2. And the square root of 3 minus 2. And this one is similar in the fact that even though I'm using parentheses because I'm plugging something in, I'm plugging a number in, I wouldn't necessarily have to have parentheses since this is a positive 1x inside of there. It's just a good habit to have parentheses when we plug it in. And then I also want to point out that inside of this square root, there are invisible parentheses as well. Okay, all right, so 2 minus 2 is 0, so I have the square root of 0, and that's just 0. And then the square root of 3 minus 2 would be the square root of 1. The square root of 1 is 1. And then the square root of 6 minus 2 would be the square root of 4, and the square root of 4 is 2. And I could verify all of these with a calculator. All right, I hope this helps. This is just a little reminder of how to evaluate functions. Have a good day. Bye.